Hi ladies, in this video we're going to do the reference angle 30 degrees. So we're going to look at trig functions, but I'm going to focus on the reference angle 30 degrees. So previous video was on 45 degrees if you're watching them in order, but this one we're going to do 30 degrees. And I think I just realized something. I might just scroll up because I did say this in the second video and I've got all the writing here. If we go back to this triangle here, oh, I just circled it, but you, you probably didn't see. Now, if I just redraw it, now in your textbook and in your notes, it actually has root 2 here and 1 and 1 on this side. Now, it's the same triangle, and basically why we use 1, 1 and root 2, there's no difference. It's just a little bit easier to remember, but they're exactly the same triangle. And if you don't believe me, basically we just multiply everything by root 2. So if we multiply, actually I don't want to do blue, it's a different color. And I probably should have done this in the previous video, but it's all good. Okay, so let's multiply that by, multiply by root 2. If we multiply this by root 2 and multiply this by root 2, so basically 1 times root 2 is where the square root of 2 comes from. Square root of 2 times the square root of 2 is 4. So, sorry, the square root of 4. And the square root of 4 is 2. And then 2 on 2, it gives you 1. And then it's the same on the other side. So if you're wondering where that triangle comes from, they're exactly the same triangle. Okay, it's just enlarged. So it's what we call similar triangles. And I think I briefly explained that in the last video, but I didn't show that second triangle. Okay, let's go back to reference angle 30 degrees. So 30 degrees, our reference angle always goes in the first quadrant. So there it is, 30 degrees. This is 0, 9, oh gosh, what's happening with my pen? 90, 180, 270, and then back at 360. All right, so this angle in here, or this sector, we can actually make into a right angle triangle. So I'm going to redraw that right angle triangle over here. What we have here is 30 degrees. Now, if that's 30 degrees, we can have 60 up here. And we're actually going to be using the same triangle to get a reference angle of 60, but I'm going to just work with 30 degrees in this video, just to not overcomplicate things, but we tend to just use the same triangle for both 30 and 60, but I'm going to separate them into a triangle with 30 and a triangle with 60. Okay, now your radius of the unit circle is 1, so your hypotenuse is 1. Now, your two other sides, this is your opposite side and this is your adjacent side. So we can get the value of your opposite side and your adjacent side by using a trig ratio. Okay, so if we wanted to find the opposite side, we could use sine. So sine 30 degrees is equal to the opposite over hypotenuse, so opposite over 1, not 0 over 1. So we're just dividing by 1, so sine 30 is equal to your opposite side. I should write OP just so we don't get confused with the number 0. Now, sine 30, if I put that on the calculator, is, oops, I did it twice, is just a half. So on this side, I have a half. And then on the adjacent side, I use cos. the cosine ratio. So it's adjacent over the hypotenuse, which is 1. So cos 30 is equal to your adjacent. So we'll just put that into the calculator. Now you get, I know what that is because I've done trig functions for a while, but you get this answer here. Now, if you want to work in exact values, don't press that button, press your document settings, and just change your calculation mode into exact, and that'll make it a bit nicer for us. So if I just scroll back up, we get root 3 on 2. Now, I might just put this over here. Now, you can also get that by using Pythagoras' theorem if you wanted to. Okay, but for the purposes of this video, I'm just going to keep going. So root 3 on 2.5 and 1 for the the hypotenuse. Now, in your notes, your triangle doesn't look like this, or it doesn't have the sides labeled like this. Okay, so what I just did before with our tan, so I made those changes, we're going to do the same here. So we're just going to tidy it up a bit because we've got a half, we've got root 3 on 2. We don't want to get rid of those fractions, so we can multiply that by 2 and that by 2. Whoops, got to write the square root. And we have to multiply that by 2. So we're effectively using the same triangle because we still have 30 degrees here. Okay, so when you change all the sides by the same ratio, it doesn't affect your angles inside. So our hypotenuse is 2, half times 2 is 1, and then root 3 on 2 times 2 is just the square root of 3. So that's why in your textbook you'll see this green triangle, but this blue triangle, I've just shown you how you get those values. All right, so let's move on to doing a little bit more for this. So I'm just trying to think what I did next in the previous video. Let's convert it into radians now. So remember, if we're going from degrees to radians, we're going to be multiplying by pi on 180. And then from radians to degrees, we multiply by 180 over pi. So to convert 30 degrees into radians, we multiply by pi on 180. So we've got 30 pi on 180. So the highest common factor is 30. So we're going to have pi on 6. So 30 degrees is equal to pi on 6 radians. Put a little radian symbol on there. All right, so let's have a look at, we've already done sine 30 and cos 30. So I know that sine 30 is equal to a half and cos 30 is equal to root 3 on 2. And if you're ever unsure, we just use this green triangle, which I might just put in a little bit of a box. Okay, so remember cos is adjacent over hypotenuse, so you can see in this green triangle that I've just put in a pink square, the adjacent side is root 3, your hypotenuse is 2, so root 3 on 2. Now what about tan? So tan, remember, is opposite over adjacent, so your opposite side is 2, and your adjacent side is, sorry, I'm looking at the wrong triangle. Your opposite side is 1 and your adjacent side is root 3. So we're going to have 1 on the square root of 3. Now, we don't tend to leave a third in the denominator, so we're going to multiply by root 3 on 3. Sorry, root 3 on root 3. So then we're going to be left with square root of 3. Root 3 times root 3 is root 9, which becomes 3. So tan 30 is the square root of 3 on 3. And that's the same for all your radians. So I might just put on the side. So this is equal to sine pi on 6. This is equal to cos pi on 6. And this is equal to tan pi on 6. Okay, so you can have the radian equivalent. All right, so I've just popped in our graphs so we can have a look at them. I'll make them a bit smaller. Actually, I'll do the sine graph first. So remember, this is your sine graph up the top. So y is equal to sine x. And then we've got the cosine graph below that. So I'll do the sine graph first. So we've just looked at 30 degrees, which is here. So if we go up, and it's actually drawn a dot for us, you can see that is halfway between 0 and 1. So there we got 0.5. Now, as we did previously for 45 degrees, we can go across and see that we hit our sine graph again. And the good thing is they've got a dot there so we can easily read it. Now, sine of 30 is the same as sine 150, and I'll use a unit circle in a second to show you. And let's just do the negative, so negative 0.5 if we cross our graph, and they've got the dot on there, so that's really nice. Okay, so it hits it twice. We can see at, so we had 150, 210, and then 330. So here we've got the solution for quadrant 1, quadrant 2, quadrant 3, quadrant 4. So Q1, without doing the unit circle, I can see it's going to be 0.5. So sine of 30 is 0.5. In quadrant 2, we've got sine of 150 is also 0.5. In quadrant 3, sine of 210 is negative 0.5. And remember that sine is negative in quadrant 3 and 4. And then sine of 330 is also equal to negative 0.5. And your graph keeps going. So if you were interested, you could actually continue to see when sine is also sine x is also equal to 0.5. Now for your cosine graph, now they also have it labeled on, but not as well. So down here is 30 degrees, which is pi on 6. Okay, and if we go up, now remember that was 0.866 something. I can't remember what it was. And that was root 3 on 2. So I'm going to just write root 3 on 2 here, our exact value. And that hits again, keep my line straight, here. And you might think, oh, but it's also there. But our whole circle, one rotation of the unit circle stops at 360 degrees. So the graph keeps going. So you can see it does hit again. And if you're actually interested in that, well, that point there is 360 plus 30 degrees, which is 390. Okay, so you can see how you can have infinite solutions. So we've looked at these two solutions. Okay, so we've got cos of 30 degrees is root 3 on 2. This in the first, so that's quadrant 1, and then we've got quadrant 4. Now, it's not written on here, but hopefully you're thinking about what that might be. This point here is just 360 minus 30 degrees, which is 330. Or you can do the radian equivalent, which we'll do in a second. All right, and then we've got the negative. So we've got negative root 3 on 2. So we can hold on. I'm just making sure. I feel like I'm doing the wrong one. Let's just double check. Okay. Sorry, I was going towards the wrong dot. We want the dot down the bottom. That's a bit better. Okay, so you can see your other two solutions here. Okay, so that's going to be quadrant 2 and quadrant 3. And that's when cos is negative. Okay, so you can see it's negative root 3 on 2. Now, if you're interested in what these angles are, this first angle here is 180 minus 30, which is 150 degrees. And you can do the radian equivalent. And then we've got 180 plus 30, which is 210. And you can see they were written on, I circled them above here, but they're written, not written on the second graph. So that's why I had to add them. Okay, so we already know what these angles are, but let's say, oh, I don't know how we got them. So let's have a look at the unit circle again. So here we have the unit circle, 0, 90, 180, 270, and then back to 360. Okay, so we did 30 degrees. Okay, so sine 30 was 0.5. Let's just change to the next one. So that angle in there is 30. So sine 180 minus 30 is also equal to 0.5. Now we just need to tidy that up. So sine 150 is 0.5. And I might not put in there the radian equivalent. You can do that from the graph. I'm just wary of time. So 30 degrees, so 180 plus 30. Now that's 0.5, but in the third quadrant, sine is negative, so it's going to be negative 0.5. So sine 210 is negative 0.5. And then in our last quadrant, what color can I do? Orange. Sine we've got 360 minus 30 is equal to negative 0.5. So sine of 330 equals negative 0.5. It's a good practice to convert these into radians. I'm going to leave that because I feel like we've done that for a bit now, but I'm going to just quickly do the reference angle 60 degrees. Okay, so you can pause here if you're getting the hang of it, but let's just do the reference angle of 60. I might do it on a new page. Okay, so I'm going to just scroll up because we already found that triangle. Okay, so we can use the triangle here that I've got in green, and I've gone around it in pink. We can use that same triangle, but I'm just thinking aloud here. Okay, let's use the same triangle. You can get a triangle from the unit circle as well, but eventually you won't be starting with the unit circle to get your exact values. Okay, so let's work with this triangle that we had before with 30 degrees. So we had 2 up here, that was 1, and then on the bottom we had root 3. Okay, so the angle on the bottom is 30 degrees. So if that's 30 degrees, that makes this angle up here 60 degrees, because all your angles inside a triangle have to add up to 180. But I'm going to only use the 60 degrees. So I'm just going to erase the 30 degrees now. And I don't like the orange, so I'm going to use a different color. There we go. Let's go back to, we'll do purple. Okay, so remember SOHCAHTOA. So this is how you would use your reference angle, okay? And you could use this for reference angle of 30. You can use this also for 45, like we've just done. So if you remember this triangle, you can get your exact values for 60 degrees, you can get your exact values for 30 and 45. All right, so let's do sine theta equals opposite over hypotenuse. So in this triangle, theta is 60 degrees. The opposite side, which is here, is root 3. And your hypotenuse is 2. So sine 60 equals root 3 on 2. All right, let's go and do cos. So cos theta equals adjacent over hypotenuse. So theta being 60 degrees, your adjacent side is here, so it's 1, over your hypotenuse, which is 2. Now what you would notice with these two is they're the opposite of what we had for 30 degrees. So remember, sine 30 was a half and cos 30 was root 3 on 2. Now they're the opposite. All right, and let's just do tan because I feel like we're forgetting tan. And if you're sitting there thinking, why aren't I doing the tan graph? It's because it's slightly different to the cosine and the sine graph. So I just don't want to introduce too much at this stage. So tan of 60, your opposite side is root 3 and your adjacent side is 1. So that's square root of 3. Now, converting 60 degrees into radians. So we multiply it by pi on 180. So we have 60 pi on 180 equals pi on 3. So you can replace all these 60 degrees with pi on 3 and you get the same thing. Now for the graphs or the values in the unit circle, now these are quite messy at this stage, but you can see, and I might put these up again, but you can see 60 degrees and the next one is going to be 120 and then 240 and 300. So if you've understood the reference angle for 45 and 30 degrees, you should be able to go and now do 60 degrees on your graph. All right, let's just have a quick look at the other values on the unit circle. This time I might do everything in radians just because we haven't really done much in radians. So 0 pi on 2, then we're at pi, 3 pi on 2, and then 2 pi. Now, if you're wondering why it's pi, remember the circumference of a circle is 2 pi r, and in a unit circle, your radius is equal to 1. So 2 pi times 1 is 2 pi. So the whole distance around your circle is 2 pi. All right, our reference angle. So our first one in here, we've got pi on 3. Okay, so I'm doing sine pi on 3 is equal to root 3 on 2. Let's move around our unit circle to the next one. So again, this is pi on 3. So this time we've got sine pi minus pi on 3. So before I said, oh, there's two ways you can actually get your radians. So we can convert, do a conversion from degrees into radians. So you could say, all right, this is the same as 180 minus 180 minus 60. But if you're working just in radians, I'll show you in a sec how to do that, because you don't want to leave it as pi minus pi on 3. Just have your denominators the same. So pi I can change, well, basically this is the same as 1 minus 1/3, but if you want to, we can just have pi written as 3 pi on 3 minus pi on 3. So 3 pi minus pi is 2 pi. So 2 pi on 3 equals root 3 on 2. Okay, so 2 pi on 3 is what we have in the second quadrant, and it is positive. Sorry, just took a while to think about what I was talking about. Okay, now this next angle here, pi on 3. Do I have space below to do that? Good. Okay, so now we've got sine pi plus pi on 3 is equal to root 3 on 2. Because we're in the third quadrant, that's going to be negative. I'm going to change that pi to 3 pi on 3, just so we've got the same denominator. So when you add fractions, it's always easier to have the same denominator. Okay, so now we've got 3 pi plus pi is 4 pi on 3 equals negative root 3 on 2. And then our last one, what colour can I do? Let's do orange. All right, so this time we've got 2 pi minus pi on 3. Again, we're in the negative quadrant, so negative root 3 on 2. Scroll up a bit. Now let's change the 2 pi so we have the same denominator. So we want it over 3, so it's going to be 6 pi on 3 minus pi on 3, negative root 3 on 2. So 6 pi minus pi is 5 pi on 3 equals negative root 3 on 2. Now I'm not going to do cos or tan because I feel like the video is long enough, but also you've probably got enough understanding now to think, well, I could probably do cos and tan on my own, and it might be a good idea to have a go at doing it, and I'm more than happy to check it for you. All right, girls, bye.